So till now we have discussed about the two cases regarding the wave equation where when the k was positive and the k was 0. So now it's the time to discuss when the k is negative, and this is the most important case for us. So case 3 will be when k is negative. So what can we put the value of k? We knew already, like if I do p square, it was a positive one, it will always be if I consider any value of p, this value will always become negative positive. But if I put a minus here, you can take any value of p here, negative of p square, the k will always become negative. So let me once again put these values. These values I'm talking about, I'm going to put them again. T double dash upon c square t is equals to k, and here it was x double dash minus x double dash over x is equals to k. So let's firstly solve for the t. Here if I write it, k c square t is equals to 0. How we can write it? We can write it like this. D square minus kc square t is equal to 0. We can put k is equals to negative p square. If I am doing like this, it will become d square plus p square c square t is equal to 0. When we talk about auxiliary equation here now, it will be m square plus p square c square is equal to 0. M is equals to negative of p square c square under root, or let me write it this way. So when I do m is equals to, it will become I pc, will be plus minus, yes, plus minus IPC. So now you see the roots, the value of m is minus IPC and plus IPC. If I say m1 is minus IPC and m2 is positive IPC, it means now the roots are distinct but they are complex. The roots are complex and distinct. So what will be the value of t? T is equals to e raised to the power, when the roots are like this, I'll do it like e raised to the power alpha t plus c1 cos beta t. I think these variables are already used. Let me once check. C8 we have used. Let me take it c9. C9 c10 sine beta t. What is alpha and beta here? Alpha is the real part of complex number and beta is complex part. So t will become, so for this alpha is 0 and beta is plus minus pc. So if I am going to put 0 here, e will become 1 and this will become c9 cos pct plus c10 sin pct. This will be the value of t. Okay, Now we need to solve for x. So when we are solving for the x, it will be x double dash minus kx is equals to 0. It will be, let's say, d dash square minus kx is equals to 0. Now here we can put k is equals to negative of p square. Once we put this value, it will become d dash square plus p square x is equal to 0. This x will be outside. X will be here. Okay, now we have put the value of k. Now we need to make the auxiliary equation to solve this. Auxiliary equation, it will be, let's say, m dash square plus p square is equals to 0. M dash square is equals to negative of p square. M dash is equals to plus minus ip. Okay, now we need to find out, like, these are again the imaginary roots, like m dash 1 is plus of ip and m dash 2 is minus of ip, which means the roots are complex and distinct. Once again, here we have to use this one, e raised to the power alpha formula. So here x will be, here alpha is 0, alpha is 0, beta is plus minus ip. These are our imaginary part. So e raised to the power alpha x, this will become, this will remove, so it will be c11 cos px plus c12 sin px. This will be the value of x. Okay, so what will be the final solution for u? U was x into t. U is equals to xc11 cos px plus c12 sin px. Now tc9 cos pct plus c10 sin pct. This is our solution for u. Now we have got three cases and the three solutions for the u. So which one we need to consider? So if we see the very first solution, what we had, the very first solution was this one, x is equal to c1t plus c2 and c3x plus c4. Is this the solution of wave equation? Like, we know the wave is in the form of this, which is the solution. We know solution. We know the wave is in the form of this. Okay, so whatever is the solution, it should be in the form of this wave. So if again I go to the very first solution here, where it is, here, c1t plus c2 plus c3x plus c4. This is some kind of a linear function. This does not seems to be a periodic function, so this cannot be a solution. If I go to the second solution where we took the k was positive, so here if we see, this is This is some function of e raised to the power px, which means it is some kind of exponential function. So this is also not our solution. But here if you see, it is a solution. C1 cos px plus sin px, we know already, like cos and sin, these are the periodic functions. So we will consider this third one, like where we are taking the k is negative. This will be our solution. K is negative, means negative p square. This will be our solution of wave equation. C12 sin pct. Now we see in this, if this is the solution, we have so many variables here. Okay, but what was the initial wave equation given to us? Is it was dou 2u upon dou t2 is equals to c square dou 2u upon dou x2, which means we have u, t, x and c. Apart from all these constants like c11, p, c12, these all constants we need to remove. So in the next video we will learn how we can remove all these constants.